Greetings, fellow muckas. Today we're going to be looking at the extreme value theorem. The extreme value theorem is as follows. A function that is continuous on a closed interval a to b has a absolute maximum value and a absolute maximum value or minimum value on that interval. The problem. For the functions below, identify the location of the absolute max and absolute min values. Do the functions meet the conditions of the extreme value theorem? So in part A, this is the figure or graph. And in part B, this is the figure or graph. Now pause this video, take a few minutes, and solve this problem. Welcome back. Hopefully you're able to solve this problem. Now let's work on it together. So in part A, is the figure or graph, does this figure meet the conditions of the extreme value theorem? So, is the function continuous? Yes. So the extreme value theorem guarantees the absolute max. So the absolute max occurs at where we have a max value, A, and absolute minimum occurs where? At C. And so for part A, the functions meet the conditions of the extreme value theorem, and we have an absolute max, which occurs at A, and an absolute min, which occurs at C. Now in part B, does this figure or graph meet the extreme value theorem conditions? No. It's not a continuous figure or graph. There we have open intervals. So it does not have a absolute min, but the figure or graph does have an absolute max. And where do we see the absolute max? Well, that occurs at the point C. Not the open interval, not this point, but this is our absolute max, the closed interval for this figure or graph. So this just shows that it's possible that a function may violate the conditions of the extreme value theorem and still have a absolute min or max, or both. We could change the figure in part B to look like this, and then now we have an absolute min at point A and a max to at point C. So it is possible. So just keep that in mind. And I hope this video helped understand the extreme value theorem. If it did, please consider subscribing and liking this video. Thank